Hi everyone, I'm recording this video for my A-level electronics students. Might also be of interest to GCSE electronics students, and I'm just trying to give you a few ideas about how you get from the very initial idea for a project to something a bit more substantive and something you can actually make progress with. Now, I need to point out that whatever I present here, you won't be able to copy directly into your own project work, and make sure that you don't, because this video is going to go online and there'll be other people on the internet somewhere probably who are going to try and copy it, but you make yourself very vulnerable to if you do that, because the exam board will most likely pick up on that. So do be careful on it. So anything I say here, use some ideas, use techniques, just let it help guide you, but please don't copy it word for word. Okay, so as you can see, I've made something in a presentation program. It's a little bit like PowerPoint, but it's not PowerPoint, just because I don't have PowerPoint on this computer. But when you're doing a project, A-level students tend to do the project in Word or a similar word processor. GCSE students tend to do it in PowerPoint or similar, just because they tend not to, GCSE students tend not to need to write so much. But there's no absolute rule to say whether you've got to do it in PowerPoint or not, or whatever. Okay, so I've just done it like this just because it makes it easy for me, because I didn't actually want to write too much. I just want to give you the gist of the thing. Okay, so anyway, let's have a quick look at the presentation. So the first thing that you do when you come up with an idea for a project, you've just got to think of what interests you, and maybe say you're interested in sheds and security or whatever. So this is what I've come up with. Okay, so it's going to be a microcontroller based project, and specifically for the A-level we actually have to do a microcontroller based project programmed in assembly. For GCSE you don't, but you could do. And so we need to identify a problem. So whether it's A-level or GCSE, you need to identify a problem, something you're going to solve. So the problem that I've got here is there have been a number of thefts from garden sheds in the local area. So there's a problem. Okay. Now, the problem that you identify might be something completely different. It might be something along the lines of, let's say you find the lighting along the side of your house to be inadequate, or you frequently oversleep in the morning, or whatever. You identify a problem, and then you see if you can elaborate on that a little bit more and you should write up a problem like this. So let's see what I've written. These thefts always take place at night. The thief always targets locked sheds that may contain valuable garden equipment. Trimmers, lawnmowers, other garden machines have been taken. Even the best door locks and padlocks are no match for this thief, as false entries always use a shed alarm is the best solution, blah, blah, blah. Okay, so all of this problem is made up. And that's not an issue at all. Okay, for whether it's A-level or GCSE, it doesn't matter whether it's an actual real world problem or one that you make up. So don't stress about that. But see if you can make it a little bit more realistic. Don't make it let's say something like you'll say you're going to save the world from a nuclear war or something like that, because you'll actually find that it's more fun and probably something you'd want to talk about, say, to a future employer, if it seems like a real world type problem. So having identified a problem or sort of scenario for the problem, you should then move on to use something called abstraction, which focuses only on the important details. I mean, for example, does it matter if it's a strimmer or a lawnmower being stolen? Probably not. Does it matter that the thefts only take place at night? Yeah, that might be key. So we're going to be using this thing called abstraction just to focus on the important details. Oh, also another very important detail here is that the homeowners are forgetting to set their shed alarm. Okay, so the next stage, in fact, let's just go back. So that is the problem, and then next we try to analyze the problem in more detail. And to do that, we should use that thing called, remember, abstraction, to just focus on the important details and maybe make a bullet point or a numbered list of points to show that you've analysed it. Now, generally in a mark scheme, there's going to be at least some mark or part of a mark towards showing that you've actually considered the problem. So let's have a look at my analysis of this problem. There is a problem with thefts from sheds. That's the obvious thing. So don't feel scared by stating the obvious. Thefts only take place at night. So that is, we've used abstraction to pull out that important detail. Door locks provide insufficient security. Homeowners may forget to set their shed alarms, and they could benefit from an automated alarm system because they were forgetting. Okay, so these 5 points are not necessarily the correct points to state, but they all seem valid, and they show that you have thought about the problem before you continue. So the next stage is generally to write a design brief, and as the name suggests, brief does mean brief or short. So it should be short and snappy, which just describes what you need to do. So I will design and build an alarm system that can be used to protect a shed. The alarm will provide security at night by automatically arming itself during the hours of darkness. The alarm will only be armed when the shed door is locked. Now, the actual functionality to this was not in the original problem. It's you've now decided that that is something you would like. Now, you don't need to go into a huge amount of detail because it's supposed to be brief, but it's the sort of thing that if you were to write this design brief, then you could give to a designer who could then, an electronics designer, who could then come up with, say, a possible circuit. But if you don't give enough detail, like for example, if you left out that it will be armed automatically, if you left that detail out, then they most likely wouldn't include that feature. Now, it'd be really good after writing the design brief if you then start to think about this further. And the way I've done this here, I've added a box with some additional thoughts. Now, there's no reason that you couldn't then do this yourself, but it doesn't have to be written like this. But you could write some further discussion to show that you've considered it. Now, you might think, well, why do I need to do that? Why don't I just write it into the design brief? Well, if you write it into the design brief, it's going to no longer be brief. And it's really important that you actually do think about the design brief further, because I've seen many times where people come up with an idea, but then they haven't really, let's say, I seem to recall in the past, we've had a student with some sort of security airlock type system, whether it's like in a nuclear plant or whether it's in a submarine or whatever. But they haven't really thought about, what actually happens when you go through one door, and they haven't said that when you go through one door, the other door should be locked or whatever it happens to be. So I've got some additional thoughts here. What type of alert system will be used? So if you've got an alarm, and if, say, there's an intruder, do you want something that sounds, or do you want something that flashes, or what? What type of input sensors could be used for this? Now, for A-level projects, for the microcontroller project, it's entirely okay to use an input sensor that's not like a real-world sensor. So, for example, you don't need, let's say if it's like a shed door, you don't actually need a pressure sensor or a vibration sensor or an actual door lock or something like that. You can just simulate the fact that the door has been opened by just a normal toggle switch, for example. That would be absolutely fine. So it doesn't need to be like a finished working project. How would the homeowner know the system is armed? So it wasn't in this design brief, but I think it'd be worthwhile thinking about that. And so, I think I would, as a homeowner, would want to know that the system, bearing in mind arms automatically, I'd want it, say, to flash or to have a steady on LED or something, or maybe, as it arms, maybe it beeps for 5 seconds. But then again, if I wasn't in the garden at that time, then I wouldn't know that it had armed itself. So I think I'd probably want to have something that was always on while it was armed. How long should the alarm sound for is another very good question. Now, although you wouldn't actually be marked down for this, I think the UK law is an alarm should not sound for more than 20 minutes because it causes a nuisance to other people in the nearby area. Now, so if you're having an alarm system, it would be good if you limit how long the alarm goes off for. Now, For a student project, having an alarm go off for 20 minutes for testing is completely impractical, and it's going to be a great annoyance to everyone. So if I were you, I would have a much shorter duration, something like 20 seconds maybe, or whatever you want. We haven't detailed here how the homeowner could reset or cancel an active sounding or flashing alarm. So do you want that feature? If you do, how are you going to do that? Is there going to be like an override switch or something? So you need to think about how that's going to work. And so personally, I would identify some of these questions that are in your mind, and then I would then write out, how you think you're going to address that. So it might actually be a good idea if you were to do this as a table, or you could do it as some sort of, just like writing it like essay style. It's up to you, okay? I'd probably do it as a table myself, but anyway. So in the design specification, you now need to have some detailed things that your product will do. For example, one specification point will be the alarm system will arm itself automatically. But that's not explaining exactly how it arms itself. So if you were to leave it like that, that's not going to give you enough detail. Now, if you go back, we said, I think it's going to automatically arm itself during hours of darkness. The alarm will only be armed when the shed door is locked. So in the specification point, it might be more like, if the shed door is locked when it's dark, the alarm will be armed, or whatever you want to do. Sorry, I just accidentally clicked there. Other points will be, okay, so let's say if we say that there's going to be a 20-second audio alert if someone goes in, or whatever it happens to be, then you need to put that as a detail, okay? And then hopefully you can add a justification to it as well, because then that's going to link back to your user's needs. Now, I really do like using this as a table, and the reason why I like doing it as a table, because for GCSE or A level, you're going to have to, at the end, you're going to have to assess whether your product actually does what you said it would be. And the easy way to do that is then to copy and paste that same table into the end of your write-up, and then add another column, and then have that column as an assessment of whether that specification point was met. Now, I've also mentioned down here that you should use objective criteria. Now, objective, well, the opposite of objective is subjective. So, for example, if you said something like, McDonald's food tastes good, that would be subjective, because some people would agree, some people would not. If you were to say, let's think of something that's objective. I don't know, driving at 150 miles an hour down the motorway is dangerous. Okay, it's not really open to debate. Now, with objective criteria, one objective criteria point might be something along the lines of that if there's an intruder alert, then the LED or whatever you want is going to flash at a frequency of 1 Hertz for a period of 60 seconds. Now, that is also a quantitative criteria, because we give a quantity there. A qualitative would be that there would be, the alarm would be easy. Well, even in fact, if you said the alarm would be easy to set, then that then becomes subjective. So it is a little bit tricky. I tend to say that it's better to stick with objective rather than subjective, and go for the quantitative things that you can always measure. Okay, but if you need to slip in some quality type specification points, I'll leave that to you. You have to think about that. I think I've got another video somewhere which actually gives some better examples, which I can't think of off the top of my head. Let's have a look at the next slide. So if you're doing A-level, it's a good idea, in fact, not just A-level, but also GCSE, it's a good idea to identify the inputs and outputs your product will use, like input. And you could have like a table with multiple rows here. One of the inputs might be, let's say, a door switch, an ambient lighting sensor, and then an output might be the flashing light alert or the siren or whatever it happens to be. By the way, there's no relationship between what's in this cell with what's in this cell. You could have done this as two separate tables, and it doesn't even need to be done as a table. It could be like a list or whatever. Okay. System block diagram as well. You might want to even skip this. It's up to you, but you could have a system block diagram where you've got like inputs over on this side going into processing in the middle, and then outputs on the right hand side. Now, logic truth table is a good thing to do. Now, this is not necessarily in any way a correct truth table. But hopefully it gives you an idea of sort of how it might work. We do these in A-level and GCSE, so you should all be familiar with this. So let's imagine that my shared sensing system, security system, whatever we want to call it, has three inputs. It's got a light sensor. It's also got a sensor whether the door is locked or not, and it's also got, say, a motion sensor. And this is not something you would necessarily do, but this is just an example. You need to identify the logic levels for each one of these sensors. So I've said that like the light sensor, it would be 0 when it's dark and 1 light. Notice that's digital. I'm not using an analog sensor here, so there would be a little bit of additional circuitry. But if it's an A-level project, you could just use a switch, and you just flick the switch, and the switch just suggests to the system whether it's a light or dark conditions. Anyway, so yeah, you fill out this. So you're going to start with the inputs, go through all the different combinations. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. So basically you count up in binary, you fill up those first three columns, and then you consider whether the system should be armed. So if you remember, when it's dark and the door's locked, then it should be armed. So that would be a 0 dark, locked will be 1, and it makes no difference about whether the motion sensor does not detect or does detect. It should still be armed. Okay, so you fill out that column there. The reminder, oh yeah, I think probably skipped that earlier, but do we need a reminder to remind the owner whether to lock the door or not? Yeah, so maybe we need to have a reminder there as well. So yeah, so maybe that's like a flashing LED or something. Port assignment, I've not done anything on this slide at the moment. In fact, I'm not sure I've done anything on the remaining slides. Let's just have a quick look. No, I haven't. But you'd normally for A-level, you would then decide, that this switch is going to go onto port B, RB0 or whatever it happens to be. Okay. System block diagram, you do need one of those. So you have your inputs, processing, and outputs. You're obviously going to at some point need to present a circuit diagram or diagrams. If you're doing the certainly if you're doing the A-level, you're going to need to have a flowchart that represents your assembly code. Okay, and there's going to be a load more other stuff as well. There's going to be testing, and yeah, but this presentation I'm showing here is not complete. Okay, it's just trying to certainly for some people, it's trying to give them an idea about how they need to really think about the problem and think about what their product's going to do before they get too much into starting to write code. Because if you just launch straight into writing code, it tends to be, in my experience, that then the product's not like viable at all, because you really haven't thought about how your product would how would you actually want it to work. Like X in a shed going into a shed or whatever it happens to be. Okay, now I'm well aware that this video is long, so I doubt many of you have really got to the end, but if you have, well done. If you think it's useful, please give it a thumbs up. I can show you a little bit of coding for this type of project as well, if that's useful. Yeah, okay, so hopefully that's of use to someone, and I'll probably post another video sometime soon. Okay, goodbye.